All right. So this is where we finished up yesterday. We were talking about multiplying two matrices together, yes? And we essentially came to the conclusion that, for the most part, doing the matrix multiplication, we're going over and down, which is not, there's not a lot of complicatedness to it. There's not too much going on. It's just we multiply over and down. But it's just as easy, if not faster, to just let the graphing calculator do it. Because the graphing calculator can multiply, add, subtract matrices. So we'll look at one more of these here. Because if we're multiplying u and v, if we do this by hand, we'd have 5, 9, negative 3, negative 2. They multiplied with 2, negative 1, 6, negative 5. Now we can multiply if the columns of the first, the number of columns that we have in the first, matches the number of rows in the second. Now since the first one's a 2 by 2, and we're multiplying it by a 2 by 2, columns of the first does indeed match the rows of the second. So that says we can multiply. And the expected dimensions of our new matrix is the column or the rows of the first by columns of the second. So our new matrix should be a 2 by 2. Now when we multiply, and we do this by hand, we're going to go over and down and multiply each element as we go. So we're going to start off and multiply our 5 with the 2, and then add to it our 9 times 6. Then we're going over and down. Now the next thing we can do is we're going to do it again. We're going to go, not erase, we're going to go over and down. So first row, second column. So we're going to have 5 times negative 1 plus 9 times negative 5. And that's it, because we only had 2 columns in the second. We're only going to do it twice. If there was a third column in the second matrix, we would do it a third time. If there's a fourth, we do it a fourth time. We're just going to go over, down each time. Does that make sense? We kind of get what we're doing here, yes? Then we're going to do this again. We're going to go over down with our second row. So we're going to say negative 3 times 2 plus negative 2 times 6. And we're going to do it one last time, over and down. We're going to have negative 3 times negative 1 plus negative 2 times negative 5. And that's the main step, the main process with multiplying. The only other thing we have to do is simplify each of those expressions. So our 5 times 2 plus 9 times 6. Now at this point here, we could plug each one of those in and let the calculator do it for us. Or we can say 5 times 2 is 10, 9 times 6 is 54. Here, 5 times negative 1 is negative 5. 9 times negative 5 would be negative 45. Negative 3 times 2 is negative 6. Negative 2 times 6 is negative 12. Negative 3 times negative 1 is 3. And negative 2 times negative 5 is positive 10. And last but not least, we add. So 10 plus 54 is 64. Negative 5 minus 45 is negative 49. Negative 6 minus 12 is negative 18. And 3 plus 10 is 40 or 50. Thank you. I knew I was missing something. Yep, thank you. Yeah, I think I'm 5 and 4. I think I saw it as negative 44 instead of negative 45. Yeah. Questions on this here? Now, if we wanted to do this in the calculator, we'd pull the calculator up, go second matrix, over to edit. And our first matrix is indeed a 2 by 2. 5, 9, -3, -2. Once we get it typed in, we're going to go second quit, second matrix over to edit. But this time we need to go to matrix B. Since we set matrix A as the first one, we need to set the second one as a different matrix. It is also a 2 by 2. 2, -1, 6, -5. So I think by this point we feel comfortable being able to get them typed in. Now all we have to do is recall it. So we put U, the first matrix, in as A, and V as B. So it's just A, B. Because when we put them next to each other, it's understood to be multiplication. And we get the exact same thing. And this here, for a lot of the matrix operations, addition, subtraction, just adding or subtracting two matrices, it's almost as fast to just actually do it by hand than it is to plug it in. I would say with some of the matrix multiplications, when we start getting bigger than 2 by 2s, the calculator is going to do it way faster than we ever could. Now we could flip it, matrix B times matrix A, and we see here it still works, but we get completely different things. When we multiply two matrices, the order matters, because if we flip it, we will get a completely different expression. Questions on any of this here? We feel good with matrix multiplication, addition, subtraction, scalars? Yes? So that's fine. So the next one would be essentially the same thing. So you would plug in JKL, each one of those into a different matrix. So you can do J as A, K as B, L as C. And then type it in just like you see it. Now there is other notes where we're talking about J times matrices, but again, most of that, we can set it as A, B, C, type it in exactly as it is, it'll do it for us. So this, no. So I would look at the 3 dimensions, because it does work, because a 2 by 2 plus a 2 by 2 works, and then if we multiply it by J, which is also 2 by 2, it should give us a solution.
Yeah, I've got them all like 2 by 2, and it's not doing anything.
Let's see. Interesting. Yep, hope that looks good. Matrix C plus matrix C. Yeah, for some reason it needs multiplication.
Oh.
Yeah, but nothing like that's going to show up on the homework on any of this here. So we kind of feel comfortable with that there, yes? Okay. Determinants. Now, the reason I'm putting these two together is because determinants are actually quite nice. Because that's the homework. I want to talk about determinants real quick. So determinants, that's that other note sheet we had. Now, determinants to find the determinant, DET, another way to know we're taking a determinant is instead of having our brackets like we normally do around a matrice, they're going to replace them with absolute value bars, or what looks like absolute values. And so it says we're going to take the determinant of it. Now to take a determinant of a 2 by 2, we're going to do this. We take this diagonal from top left to bottom right, we multiply those two numbers together. And we subtract from it the product of our top right to our bottom left. And that's the determinant. So, if we look at this first example here, we're going to have our top left to right, 5 times 9, and we're going to subtract from it our other diagonal, negative 4 times 8. So we're going to do 5 times 9 minus negative 4 times 8. So we're going to take product of top left to bottom right and subtract from it top right to bottom left. Well, 5 times 9 is 45. Minus negative 4 times 8 is negative 32. Well, our negative makes a positive, telling this matrice's determinant is 77. Questions on this here? Now we can do this in the calculator, but realistically, and we can go through it and show it, but is there really a whole lot of reason to do it for a 2 by 2? No, because we're doing what? Because even on the next one, we're doing 0 times negative 11 minus what? 6 times 4. Well, what's 0 times negative 11? 0. 6 times 4 is? Well, telling us this determinant is negative 24. That's it. Questions?
But I just plugged in 2 minus 0 and calculated.
We gave you what? 7? What do we think of 2 by 2 determinants? We like these? Yeah. Because even if we look at these next two here, negative 6 times 8, top left to bottom right, we're going to subtract from it top right to bottom left. Negative 6 times 8 minus negative 7 times 10. So we're almost, the diagonals going from left to right decreasing. Top left to bottom right are going to be on one side, and we're going to subtract from them the diagonals going from top right to bottom left. Negative 6 times 8 is negative 42. Nope, negative 48. Minus negative 7 times 10 is negative 70. Negative makes a plus. Telling us that this here is 32. We agree with that. Seven times negative 4 minus 5 times 9. Negative 28 minus 45. 5, 6, 7, 8. So 3. Carry the 1. I believe it should be negative 73. You get something different? 27 on the first one? 22. Yes, you're right. Thank you. I forgot to carry the 1. Yeah, because if we add 2 to 8, we should get 50, and then 2 more to get 70. Thank you. Questions on this here? Yeah, because doing it in the calculator is not bad. It's DET, and then it does it. Or did you just do -8? -6 times 8 minus -7 times 10. Yeah. Now, 2 by 2s are nice. One diagonal, one diagonal. 3 by 3s, we can still get a determinant. But we have a few more steps. Now, I will say this, we cannot take a determinant of a non-square matrix. So if it's a 2 by 3, we cannot have a determinant of it. It has to be square. The dimensions have to be the same. Now, we have all this. We have ways to do it. Now, the first thing I would say for this here, we're doing it by hand. Rewrite it below it. So I want to rewrite it because we're going to have to write some stuff out with this to make this thing work better. It is possible to do it just in the matrices, but we're going to start wrapping around itself. What we want to do is rewrite the first 2 columns next to it. We want to rewrite those first 2 columns next to it because we are still going to do top left to bottom right diagonals subtracted from top right to bottom left. We're still doing that subtraction, but there's more than one of them now. Because now, I'm going to get my highlighter back out. 4 times 2 times 9 is still one of my diagonals. But I also now have these 2 here. We actually have 3 diagonals that we're keeping track of. That for later. So for our first set of diagonals, we do have 4 times 2 times 9. We have -8 times 6 times -4. And we also have 3 times -3 times 5. And I will scroll down here. So these are our 3 diagonals that we're going to multiply together. That's going to be one of our numbers. We'll multiply those here in a second. But we also have our other diagonal, which, okay, I was hoping to keep the highlighter. That's not a highlighter. Because we do have -8 times -3 times 9. But we also have these other 2 here, 4, 6, 5, 3, 2, -4. We do have those 3 diagonals going in the other direction. Does this make sense? Now, we don't necessarily have to rewrite it. So I will show you all this here. So if we look at the original one, I'm going to use light blue for this. 4, 2, 9, we can see that first diagonal, yes? If I go over one, -8, 6, well, I hit the wall, yes? So really what we're doing is wrapping around to the other side. That's why we wrote those 2 next to it. Because it is -8, 6, -4. And the last one would be 3, -3, 5. Instead of processing in our head where we're wrapping from the left to the right, where we're wrapping around it, we put the 2 next to it so we can see how the diagonals actually cross. Does that make sense? So this, instead of trying to figure that out and how we are wrapping around, we put those first 2 columns next to it so we can see our 2 sets. Now the other set of diagonals going in the other direction is -8, -3, 9, 4, 6, 5, and lastly 3, 2, -4. Questions on how we found these diagonals and these product of numbers? Now we need to multiply. So we can start with 4 times 2 times 9. Well, 4 times 2 is 8. 8 times 9 is 72. -8 times 6 times -4. Well, we know it'll be positive. 8 times 6 is 48. 48 times 4, 48 times 2 is 96, 192. Yep. And lastly, 3 times negative 3 times 5. 3 times negative 3 is negative 9 times 5. And since we have those three diagonals, we're going to add those three together because that's the sum of our diagonals going from the top left to the bottom right. So 27, 219. Okay. So our one set of diagonals is 219. We're going to do the other side. Negative 8 times negative 3 times 9, 24. 24 times 9, 6, and 216. Yep. Then 4 times 6 times 5, because normally we'd say 4 times 6, but 5 times 6 is 30. 30 times 4 is 120. And lastly, 3 times 2 times negative 4. 3 times 2 is 6, times negative 4 would be negative 24. Negative 8. Or 12. So we feel comfortable in how we got these two numbers, yes? So what did we do with the 2 by 2s? We took the number from top left to bottom right and subtracted from it the diagonals that went from the top right to the bottom left. And that's what we're doing. We're doing the exact same thing. 3, carry the 1. And I believe we get negative 93. So here's the question. Is the amount of time to do a 2 by 2 to a 3 by 3 significantly increased? Okay. So that's not what I wanted. Let's actually see how the calculator, if we wanted to type this in, how we would type it into the calculator. So instead of doing this one here, well, we can do this one here. So what we're going to do, the first thing we're going to go as well, we do have to type the matrix in. That's going to be the first main step. So I'll do the first, the one we just did for negative 8, 3, negative 3, 2, 6, negative 4, 5, 9. I got off.
How do I get that table again?
Second, x is negative 1, second matrix. Then go over to edit and then select one. I think I keep so 3, 2, 6, negative 4, 5, 9. There we go. 4, negative 8, 3, negative 6, 2, 6. Yep. So for the most part, we feel comfortable getting it typed in, yes? Once we get it typed in, we're going to go second matrix. Thank you. Now, we're going to go over one to calculate because we were finding the reduced row epsilon form, RRE, if we're doing operations or stuff we want to do with matrices. We go to second matrix over to math. Yes? Now, we need to find the option that is determinant. Oh, the first one, DET, determinant. DET, first three letters. So we want to select that. So DET, second matrix A. And it tells us it is negative 93. Isn't that what we also found? Yeah. So like I've said so far with most of these things, there's a lot of stuff with matrices we can do by hand as fast, if not a little bit faster than the calculator can, or typing it into the calculator. But then there are some things that the calculator is going to do way faster than we can. And I think 3x3 determinants is one of them, yes. The only time it wouldn't do it faster is if we have multiple zeros as elements. And then some of those diagonals are just going to zero out. It's going to be nice. Questions on determinants? That's it. That's all there is with determinants. That is also why I felt comfortable finishing up yesterday's lesson and throwing this one on top. So this is our determinants. 2:06, so 15 minutes. Yes. Yes. So worksheet for both. I'm going